Hey folks, so in this video we're going to take a look at how to actually construct our topological sort algorithm. So what can we do? Well, we can actually already leverage something we have. So we've already seen DFS and BFS. We can actually use one of those. Specifically, we can use DFS. Now, in general observations are the following. Both DFS and BFS move through a graph in a specific order, right? There are rules. Go depth first, go breadth first. I have these rules, and if I were to run an algorithm multiple times on my graph, I would get the nodes out in a specific order, right? Well, that order maybe has some usefulness to it or some purpose to it, okay? So it's this that we'll actually be able to leverage. Now, going back for a little while, we can think about tree algorithms, right? So tree traversal algorithms, we had basically a notion of, for example, pre-order, in-order, and post-order traversals, okay? These are ways basically of writing down our nodes as we explore through a tree. So the thought is this: maybe I can do the same thing for a graph. Maybe as I move through the graph, I can write down things in a pre-order, an in-order, or a post-order. And so that's actually what we're going to explore here. So we're going to look at three different ones. We're going to look at pre-order, post-order, and then post-order reverse. Okay, so those are the three ones we're going to look at. And we're going to specifically look at these for DFS. And the goal here is actually that one of these orders will be the order we need to compute a topological sort. Okay, let's take a look at the code and see what this even means. So I have here basically DFS, because DFS is kind of my gold standard for things I can easily manipulate. And I have kind of standard code here. So I've edited it from the base code though to basically include recording a pre-order traversal and then reverse post-order traversal. So let's look through that. So first of all, what does it mean to have a pre-order traversal of a graph, right? So I know that DFS is going to go and look at every single node in my graph. So that's cool. What do I do here? Well, I changed a few lines. I changed this line over here, this line over here, and then this line over here. So I added a new instance variable, that's a queue, right, to store the things that I see. Then I initialize it, right, in the constructor. And then in DFS, right, as my algorithm moves to the tree, basically I'm going to add each node to the preorder as I see it, right? So I'm just making a note, what did I see as I move through the tree, right? That's all I want to do. So that's preorder. So it's really not all that bad, right? And so if I were to run this code, I would basically get back a list that contains all the different nodes, and they would basically be those nodes in the order where I wrote them down before I explored them in terms of the order that DFS sees them, okay? The preorder for DFS. So that's all cool. The second one I have here is reversed post order. So that one over here is basically this line, and this line. And I suppose this stuff here as well. Kind of the same deal, right? So I have a new instance variable. This time it's going to be a stack though. The reason why it's stack is because I'm implementing actually reverse post order. And so a stack basically reverses things, right? If I throw a bunch of things into a stack and then take them back out, basically it reverses the order that they're in, right? Since the most recent thing I've added, right, will be the first thing back out, it's going to basically flip things, right? So if I want the reverse of the post order, I'll store it inside of a stack. If I want just the post order by itself, I would use a queue like I did for pre-order. So up there, right, I have basically my new stack. And then you can see over here, I initialize it, just over here in the constructor, same thing. And then I write it down. Right? I write down whatever it is that node added to that stack, right? So here you can see I have the final line here, right? So reverse post.push of v. Basically, it's like once I'm done doing this DFS algorithm on this particular vertex, write it down, give it to this stack, right? And now if I wasn't doing reverse or post order, I would maybe have a line that says like, post.add of v, something like that, right? Because maybe if I was just getting the normal post order, I would just need to basically write down what it is that I saw, right? I write it down in a queue. But here I'm looking for the reverse post order, so I'm actually going to use a stack, and then I have to push stuff onto it because hey, that's the way stack works. At the bottom, all I have is another helper method to basically return. This is the return the stack that contains all of my nodes, right? That are going to be in post order, right? So yeah, so not so bad. So this is my augmented DFS. I haven't added that many lines. Really, what I'm just doing is writing down nodes when I see them, right? So I'm going to write them down right before, and I'm also going to write them down right after, and then for the ones I write down after, I'll put them in a stack so that I can reverse them. So again, right, this will give us basically our pre-order and our reverse post-order traversal for a graph in terms of the DFS algorithm. So this is what we're doing here. And my claim to you, and this is what we're going to talk about in the next video, is that our reversed post order is actually going to be a topological sort. So maybe take a few minutes to think about that. In the next video, we'll talk about why.